So this is from 5, right? From 5, I have to check first whether it's from 5 or from 4. Okay, class, good morning. 5 size 1 and 5 size 3. Okay. So first things are regarding your this work, your folder need to be passed up one, right? Okay, let me see the list first. 5 size 1. 5 size 1, I think still got one student haven't passed up, you know. Li and Ming here or not? Li and Ming, are you here? Lim Yan Ming, sorry. And Wan Zichin, Esther 1. Esther 1 here or not? There are 2 of them haven't passed up. Esther 1. And also Lim Yan Ming. Both also not here. You know what happened to these 2 girls? 5 size 1. Singin, Lim Singin, are you here?
Yes.
You know what happened to this Esther or not?
Don't know.
To know what happened. Where she stay, Esther 1. You don't know where she stay. Lim Yan Ming, anyone knows her or not? Lim Yan Ming? Later, I think I need to call them. Okay, 5 size 1. Okay, then size 3. Gavinish, please, 5 size 3, the friends here, please inform this boy to pass up, okay? Gavinish. Sirin, Mohammed Sirin, okay, please tell him to pass up as soon as possible. Haris, Aiman, are you here? Aiman. Aiman, Haris, are you here? Not here. Richmond, go. Mu Zixiang, are you here? Mu Zixiang.
Yes.
You got contact with Richmond or not? Tell him to pass up, can or not?
Okay.
Another one is Lutras. Janani, where are you, Janani? Janani, can you hear me? Okay, please, Janani, please tell this Lutras to pass up. Ask him to pass up his work, okay? Wong Chuan Kun. Tell him to pass up, Wong Chuan Kun. Yong Jia Yi. What happened to this Wong Jia Yi? Yong Jia Yi also never pass up. Okay. For those who did not pass up one, I give you another until Friday, until tomorrow. Tomorrow is Friday, you know. So they have to pass up by tomorrow. Okay. So this morning I went to check. There are 2 students pass up already. 2, they take the pictures and then they send me. So I go and collect. So I got the file already, 2 of them. Okay, come. I don't want to waste so much time on those who are not keen to study. I have to use the word not keen to study. I don't know why. You cannot pass up homework. Show that your attitude, you are not keen to study or not concerned about your study. Okay. All right. So this morning, so I will continue our lesson. Okay. Come, I start sharing the paper with you all. All right. I think our last week we started here, chapter 2, correct not? How is it correct? We started here. Just started
Yes.
chapter 2, correct?
We already finished this part.
The assumption all finished now. Okay, this part finished or not? Not yet. The second part, have we finished?
No.
Okay,
No.
come. Now we look at this part, okay? The second part. Assistance of guest pressure based on kinetic theory. Okay, now we are going to understand, why there is gas pressure. Why? What is the reason gas can exert pressure? Okay, now please highlight here now. Based on the kinetic molecular theory, gas molecule move freely and randomly. This one from sin lower form, you know already. The gas are moving freely, the molecule of gas are. They are moving freely and randomly. Randomly means in all directions. The gas molecule collide one another. Okay, this is important. While the gas molecule are moving around, so they might be collide. Okay, gas molecule collide with one another and also collide with the walls of the container. This is important. Please highlight. So there are two types of collision when the gas are moving in a gas molecule. Okay, I told you before, right? Gas pressure only occur when the gas are captured inside a container. That's why must have a wall container. If the gas not captured in a container, no point we discuss because there's no pressure. So the gas pressure only occur when the gas is captured in a container. That's it. Okay, so remember, when the gas pressure is captured in a container, right? So the molecule are moving around. So there are two types of collision can happen. One is collision among the molecule of gas. Another one is collide with the walls of the container. Two types. Okay, okay, next. Collision of gas molecule with one another is elastic collision. You know, in Form 4, you learn elastic, inelastic collision, right? So the collision of gas molecules is categorized as elastic collision. Okay. After they collide, they bounce back. Okay. Okay. The collision of gas molecule with the wall of container. This is special. Okay. Collision of gas molecule with the wall of container is special, because it produces change of momentum. Why got change in momentum? Because when a gas molecule hit the wall, it get bounces back. So change in direction happen. When change in direction happens, so meaning that change in momentum also happen, right? Collision of gas molecule with the wall container produces change of momentums, and therefore change in momentums is another form of impulsive force. Also, you learn in Form 4. Okay, remember impulsive force is occur when the gas molecule collide the wall of the container. Okay, so you have impulsive force. Now, impulsive force exert pressure on the inside container because pressure is force per unit area. Okay, because the impulsive force act on the surface of the container, so it turns into pressure. So this is important, okay, class. You all must know how to explain how gas pressure come. So very simple, you just remember, gas pressure come when the gas molecule collide the wall. Once it's collide the wall, you have change in momentum. Change in momentum will produce impulsive force. So this impulsive force is acting on the wall of the container. So force per area happen. So when force per area it turns into pressure, that is how the gas pressure come. Okay. Another types of collisions are among the gas molecule to another molecule, right? This one doesn't produce any pressure. So remember that the gas pressure comes from collisions of gas molecule to the wall only. So I make it very clear already. Listen. Okay, next one. Conclusion. Okay, highlight. Gas pressure is a force per unit area exerted by the gas molecule as they collide with the walls of the container. This is very, very, very important. Okay. The gas pressure is force per unit area exerted by the gas molecule when they collide with the wall of the container. So it's very obvious here. Only collision of gas molecule with the wall can produce the pressure. Understand? Li Si Yuan, understand? Ali Yishuan, understand?
Yes.
Li Yishuan, can you repeat what I said just now? Can you repeat? Yishuan, please repeat what I said.
Gas pressure is the force per unit area exerted by the gas molecule as they collide with the walls of their container.
Yes, very, very good. Okay, Yishuan, thank you very much. She can repeat exactly what I say. I mean, she pay attention, she focus, So I hope more students are like that. You're able to repeat what the teacher say means you are focused, you are paying attention. Okay, come, next move on. The next, please take out this diagram. Okay. What happens if the volume inside a container decreases? For example, like this, you have one container here. Inside this container, you have, I think it's 12 molecule of gas. Please copy exactly 12, 12 molecule of gas. Then next diagram show that when you compress, when you push the piston down to decrease the volume, but the number of molecules here remains the same, still 12 inside. Okay, please copy the diagram first. Okay, copy now, everyone. And for non-stop coming in, I don't want to see a while like the teacher asking this and that. Okay, finish copy the diagram. And this morning, we have Sejarah paper SPM, and then we have two students. They have symptoms of COVID. Symptom lah. They have soft throat, flu, two of them. When we check their form, they declare they have this symptom lah, soft throat and flu. So the ketua pengawas put them in a special room. They're so scared about this kind of thing. So they put these two students inside a special room. So we call it Philip or Bereksan Has. So one room, only one student. So two students sit in two different rooms. So fun now. Then they cannot come up, because paper one, you have break 1 hour, then only paper two. Then between the 1 hour break, the students are not allowed to come up, the two. So they have to sit inside the room. So food have to be sent to them. Then when dismissed later on 12:30, even worse. So we have to let them, these two, go out first. Go out, then cannot wait, the parent might wait outside. Immediately they leave the school gate, they go up to the car. So many procedure now. Then other student only can come out. Then the police also come. So fun because of two students, more so many people. Then later on, the police 12:30 will come and check how we handle the two students, how we handle the other student. It seems like the teachers are very free now. Okay, you all don't know what happened in the school. Very when they sit for SPM, very, very troublesome now. Okay, come now. When you look at these two diagrams, right? Okay, in terms of volume, very obvious lah. This volume 2 V2 smaller than volume 1, correct not? What about pressure then? I want you to tell me pressure 1, pressure 2. Who is bigger or the pressure still the same? How do you think? When your volume decreases, V2 smaller than V1, right? Volume. What about the pressure? Pressure 2 and pressure 1. Okay, Vera Lim? Vera Lim,
Yes.
can you tell me the pressure 2, pressure 1, what happened?
The pressure 2 is higher.
Yes, correct. The pressure 2 will become higher. Can you tell me why or not, Vera? Why pressure 2 is higher? You look at this, you look at this small red color arrow I draw. The small red, the tips is there, The small arrow, red color arrow.
Collide to the wall with the wall.
Yes, because When the volume becomes smaller, right? More gas molecule will collide with the wall. The frequency of collision become higher. So when the frequency of collision with become higher, it will increase the pressure lah. That is the reason nah. Okay, thank you, Vera. Okay, so now copy this answer. Volume 2 smaller than volume 1 and pressure 2 higher than pressure 1. The reason is here. Frequency of collision with the wall of container increases. Therefore, the pressure increases lah. When you have smaller space to move around, right? So the molecule will collide with the wall more often lah. So frequency collision increase, so it will increase the pressure. Okay. Copy the answer, everyone, please. Okay, done, huh? Okay, come. And now serine coming in. Okay, next you take out this diagram now. Okay, this diagram. What happens if the number of gas molecule in a container increase? And now you put more gas inside. So first diagram, you have 9 molecule of gas. Then second diagram, I think you have 15. Yeah, 15 molecule of gas. You have more. You put more gas inside, so more gas molecule lah. But the volume same. So what happened now? Pressure 1, volume 1, pressure 2, volume 2. So what are the relation now? P1, P2, V1, V2. What are the relation? Huh? Okay, come. Let's hear from who? Kathleen Yao. Kathleen Yao, can you come up, please, Kathleen?
Yes, sir.
Put your mic closer to your mouth so that I can hear your voice louder. Kathleen, can or not? Kathleen, I want to ask you, by looking at these two diagrams, what is the relation between V1, V2, the volume? Volume how? V1, V2?
V2 is higher.
Yeah, you, you see the volume of container or volume here and volume here got different.
V1 is higher.
No, actually, it's my mistake. It was my mistake. Actually, I means the container same size one. When a container same size means the volume should be the same. Kelly, okay, understand? Mean volume here
Yes.
and volume here same. Okay. So now we say volume 1, volume 2 same. Okay, it's my mistake because I see this volume become smaller. Actually, become the same. Actually, the volume same. What about the pressure? Kalin, you? Pressure 2, pressure 1. How do you think?
Same.
Pressure 2, pressure 1. When you have more gas inside, what happened to the pressure?
Higher pressure.
Yeah, correct. This pressure now is higher than this. Okay, now, so you can write here, volume 1 same as volume 2, the volume same, but the pressure here higher than here. When you have more gas inside, more gas molecule collide the wall, right? So you will have higher pressure. Okay, the reason to explain here, same as above. So you just write same as above. It's the same. Because when you have more molecule of gas, right? So the frequency of collision definitely will increase. Frequency of collision with the wall or container getting higher. So this will increase the pressure. Okay, understand? Ping Hao, do you understand?
Yes.
Okay, come next diagram. Please copy this diagram now. When you heat up the gas, same container, same number of molecule of gas. The only difference is now you put fire. You start the fire to heat up the gas. Here, just normal temperature, no heating up. This one you heat up. So now, Please write the relation between V1, V2, P2, P1 and give the reason. Okay, do it now. Okay, finish diagram. Okay, now I want to hear from someone to give his or her comment. Okay, let's hear from Denise Gan. Denise Gan, where are you? Denise Gan, where are you? Can hear me or not? What happened to this girl?
Yes, sir.
Denise Gan, okay, can hear now. Denise Gan, what happened to your good friend? This Gan, what happened to your good friend, the one sitting beside you, Esther one? What happened to her? Why she never follow the class? Do you know or not?
Don't know, sir.
No contact with her.
No.
Help me to ask her ask her to join the class. Okay, don't like that. And then pass up homework never pass up, never join the class also. And another girl sit beside you also is Lim Yen Ming also. You can contact her or not, Lim Yen Ming?
Don't know. I cannot find her.
Cannot find her no phone number one.
She no see message.
Why like that one? What happened to her? Both also sit beside you, Denise Gan. So you please help me can or not? Help me to inform them
okay,
please
sir.
follow the class and also pass up the work. Okay, thank you, Denise. Okay,
yes,
Denise,
sir.
when you look at this diagram okay, in terms of volume, volume 1, volume 2, how? Volume 1, volume 2. Volume here and volume here. What is your comment on volume?
Volume same.
Yes, volume same. What about pressure? Pressure 2, pressure 1. This one will heat up, this one you don't heat up. So what happened to pressure 2, pressure 1?
Pressure 2 is higher than pressure 1.
Yes, very good. But can you explain why the pressure 2 become higher now? Why when you heat up, the pressure 2 become higher, Denise? Why?
Because got more kinetic energy.
Yes, correct. Because when you heat it up, it will move faster. Yes. Okay, hold on. Okay. Kenapa cikgu Asmi? Kehadiran nggak saya semua datang aja. Dulu ada kelas. Okay. Okay, come. Denise, sorry, Okay, Denise, just saw what you say already. You say why the pressure become higher. You say what?
Because got more kinetic energy.
Yes, correct. Because when you heat up, the gas molecule will move faster. When you move faster, more kinetic energy. So more kinetic energy means it will collide the wall more often. It move faster, so it will collide more often. So this will increase the pressure. Okay, thank you very much, Dinesh. Okay, now copy the answer. Magnesium now only coming. What happened to this boy? Oversleep. Okay. Gas molecule move faster because when you heat up, it will move faster, right? So frequency of collision with the wall increases. Therefore, pressure increases lah. So all this you understand already, Okay, please copy all the answer. Okay, done, everyone? Okay, now we move to the next one. Okay, next one is measuring gas pressure. Over here got a lot of things to study, you know, class from 5. How to measure the gas pressure? Okay, the first thing you learn is manometer. Using manometer, we can measure the gas pressure. Okay, manometer means a U-shaped tube lah. U-shaped glass tube, so we call it manometer. You can use a manometer together with the oil or mercury you put inside, or you even put water also can. So you connect this one to the gas in the container, and you can measure the gas pressure lah. So this is very, very simple method now, Okay. So what happened in this case, when you open the tap, so the gas will come out. So it will exert pressure here, you push. Gas pressure will push. Then this oil here will go down. So this part will go up. So you measure the difference of the level lah. So by just measuring the difference of the oil level or water level, you can roughly estimate the gas pressure. Okay, in this case, to understand the gas pressure here, so we take 2 points which are same level, this point and this point. You must choose the same point, you know, so that the pressure are the same. So by looking at here now, pressure of gas is here, same as the pressure at this point. So pressure of this point, including the atmospheric pressure plus these columns of oil. So atmospheric plus pressure from these columns of oil will be equal to the gas pressure. Or you can see like this. When you open the gas push down, this one go up. Common sense tell you gas pressure higher, right? Not higher, this one go down, here go up, mean the gas pressure is higher than the atmospheric pressure. Okay, so in that case, you know the gas pressure higher, so you add atmospheric pressure plus the pressure of these columns of whatever oil or mercury. Okay, so this is the first one. Okay, the second one. Second one is when you open the tap. Now you see the gas not push the thing down, you know. In fact, you see atmosphere push it down, here go up. So very obvious the pressure of the gas here is lower than the atmospheric pressure. It's lower. Atmospheric pressure is higher. You see here come down, this one go up. So meaning that the gas pressure inside actually is lower. When lower means you minus, okay? You take atmospheric pressure minus this column of pressure, right? So you get the gas pressure. Yeah, minus. Okay, next, third one, equal. You see both levels same. When you open the tap, the gas come out, but the levels are equal. Equal means the pressure same now. Gas pressure same as exactly like the atmospheric pressure same. So these are the 3 methods, you know, using manometer to measure gas pressure. Okay? Can I understand? Emily Fan, do you understand?
Yes.
Okay, thank you. Good. Ho Wan Yin, understand?
Yes, sir.
Ho Wan Yin is very tired. Now she rushed here and there the whole morning. I saw her running in the school. Okay, now she's at home already. You want to discuss about what, Ho Wan Yin? The scouting. Okay, she's very secret. If you want to tell me, it's okay. Okay, Pan, do you understand? Pan Juye? Pan? Ufa Pan, understand? Pan no respond. Okay, never mind. Maybe you cannot hear me. Pan, okay, can I understand? Pan.
Yes.
Okay, come look at example 1. The figures show the manometer containing mercury. So here you have mercury, you know. The gas is here. So when you open the tap, the gas come out, then you see the level become like that. Okay, now your job is calculate the pressure of the gas in the unit cm mercury and Pascal. Okay, come now. Since the question asked this already, they want you to give the gas pressure in terms of cm mercury, Hg is mercury, and the other one is in terms of Pascal. Okay, now there's something I need to tell you first. Can you look at here first? Okay, come. You look at this diagram. Okay, here is here. It's just this diagram only. Listen to my explanation. You have a long tube. This tube is very long, 100 cm lah. So you have mercury inside. Hg is mercury. You have mercury, full of mercury inside the long tube. So what happens is when you inverted it, you put in a container to allow the mercury to come out. When you inverted, you put in a container, the mercury will come out, right? But surprisingly, every time when you repeat many times, you will notice at the beginning, the mercury will come out. But when reach the level 76 cm, the mercury will stop. It never come out anymore. One time you do like that, you do 100 times, 1,000 times, also the same. Every time that the mercury will start flowing out, but until 76 cm, it will stop. Why? Very funny, why the mercury stop at 76 cm? Who stopped it? Who stopped the mercury from coming out? Nicole Chua?
Yes.
Who stopped the mercury from coming out? Nicole?
Atmospheric pressure.
Yeah, the atmospheric pressure, the pressure outside here. The atmospheric pressure was the one very naughty, preventing this mercury to come out. Because of this, the scientists make the conclusion now. Every time it's of 76 cm, right? So we say the pressure of 76 cm of mercury is equivalent to the atmospheric pressure. This is the meaning of that. So every time, the atmospheric pressure can support the weight of 76 cm of mercury. So conclusion is atmospheric pressure equal to 76 cm of mercury. Understand, class? Eng, understand or not? Eng, do you understand what I say? Can, okay, then Tan Mei Chen, do you understand what I say? Tan Mei Chen, no news from her. Okay. Wu Zixiang, understand what I say?
Yes.
Understand. Aiman, do you understand what I say? Aiman? Janani, do you understand what I say? Yes, okay, thank you, Janani. Okay, So, okay, so meaning that, remember, atmospheric pressure equal to 76 cm mercury. Sometimes it's 76, but sometimes some books will say 75 cm mercury. It's okay lah, Okay, what about when I replace the mercury using water? How do you think? If here no more mercury, now put water. Okay, if water class, this one will be very long. It becomes 10 meters. Okay, so remember now, atmospheric pressure equal to 76 cm of mercury, and when it is water, it will equal to 10 meters of water. 10 meters, very high, 10 meters of water. So these few things you are going to learn. Okay, all right, let's go back to the question just now. It's here. Okay. So this question is saying, first the one in cm mercury, second the one in Pascal. Given density of mercury, this value, and atmospheric pressure 76 cm mercury. Okay, the first question you just answer like this. When you see the gas open, you see this one come down, this one go mean gas pressure here higher. So higher you plus atmospheric pressure plus 15 cm of mercury. Then you get this answer. Okay, 91 cm. Atmospheric here 76. Here another 15 cm mercury. So it's 91 cm of mercury. Okay. So this one is in cm mercury. The next one, they want it in Pascal. Okay, they want it in Pascal means you have to use a formula, you know. The formula you use is rho Hg. You learn in lesson, how to say lesson 1. Because mercury 91 cm, right? Mercury is a type of liquid. It's a liquid. Mercury is liquid, okay, class? So liquid means I use liquid formula lah. Density rho, multiply the depth, multiply the gravity. So you get this answer, okay? In terms of Pascal, so use rho Hg. Rho, density of mercury, very big, huh? And the height or the depth change to meter, 0.91. Just now we said 91 cm, change to meter. And gravity is 10. So you get this answer. 123760 Pascal. This one is in terms of Pascal. This one is in terms of cm mercury. Okay? Clear or not? Regime, understand? Regime, lim.
Yes, sir.
Yes, sir. Nicholas, where are you? Nicholas, understand?
Yes.
Okay, Chan Eng Sing, understand? Chan Eng Sing?
Yes, yes.
Okay. And another one is Tan Yong Kiet. Tan Yong Kiet, are you there? Tan Yong Kiet? Tan Yong Kiet, are you around? Or cannot talk, so he types Sudina. Okay, yes. Understand or not, Yong Kiet? Yong Chun Ki. Where are you, Yong Chun Ki? Understand? YCK, Yong Chun Ki, understand? Do YCK come out like this? He say yes. Okay, thank you. Okay, next question. Golden gauge. So remember that to measure gas pressure, first we use manometer. Second, use Bowden gauge. So we call it Bowden gauge. Okay. This Bowden gauge, you can always see this is a small meter on fire extinguisher. When you see the fire extinguisher, on top there's a small rounding meter. This one, Bowden gauge. So this Bowden gauge is used to measure the gas contained in a container. So for example, like fire extinguisher, easily you can see this meter on top, Bowden gauge. We need the Bowden gauge near this fire extinguisher to indicate whether the gas inside the fire extinguisher is still valid or not. Okay. All right. Now, how this thing work? Very simple. You see that when the gas push, when you measure the gas, right? So the gas will apply pressure, push to this metallic tube. This is a tube like that, like a question mark. So we call it curved metallic tube. And this metallic tube will be straightened by the pressure of the gas. When the gas push in, so this thing will become straight, try to become straight now. So this one go up. Because it's quite soft one, you can move one when you have pressure, it will try to become straight. When this thing is moving, right? Moving, so it will cause this pointer to move. Move here. When you apply gas inside, the gas will make this one to become straight. This one move, so the pointer will deflect. Okay. When the pointer deflect, you can read from the scale here, what is the pressure? Okay, that's it. Very simple, straightforward. Okay, read here. When a gas supply connected to the Bowden gauge, the pressure in the curved metallic tube, the pressure inside this tube, will try to straighten it, straighten the tube. So we will make this part to move. This movement will be amplified to move the pointer, okay? Hence, the pointer will rotate. The magnitude of gas pressure can be read from the scale of the gauge. You can read from here. So in the school, the fire extinguisher, you can see that got green color, green zone, got red zone. Why got green, got red? Do you know or not? Amanda. Amanda Lee, where are you?
Yes, teacher.
Amanda lah. I'm sure
Ah.
you have seen this before, right? You see got red color zone, green color zone. Why they put red and green there? Do you know or not?
I don't know. I didn't see this before.
Yeah, in the school got so many fire extinguisher you never see.
Oh,
Okay,
right. Okay, yeah, saw.
why got red color, got green color one? You know or not?
Don't know.
You know. Okay, let me ask boy now. A boy usually will know one. Nicholas. Nicholas, Nicholas, can you tell me why must have red zone, green zone? That one is for what?
To indicate the pressure.
So
The
red
weather
means what?
can use on.
The red means what? The green means what?
Red means cannot use already.
Why cannot use?
The pressure is not enough.
Yes, you see Nicholas very good. He knows. Red color means the pressure gets too low already. Too low means I cannot use already. The pressure too low. So when you see the pointer is still in green zone means the pressure is still enough. So meaning that gas still got enough gas inside. Hey, next time you must learn a little bit now. Okay, this one common sense, no? Red color, green color, to see the pointer. When the pointer is pointed to the red already, you must quickly go and inform Mr. Lim, say, sir, this fire extinguisher is expired, cannot be used. Understand? That is common sense. Okay, all right, done, this one. Amanda, now you understand or not?
Yes, teacher. Yes.
Yes means what? No?
I understand already.
Okay, okay, thank you. Next. Okay, next is another functions of another use of YouTube. Okay, this manometer lah, I tell you, this manometer can use to determine the density of another liquid. Okay, example is here lah. This is a YouTube. You put two types of liquid which they cannot mix. One you put that inside. This is liquid A. This is liquid B. So they don't mix one. You see what happens is this is lower. This one higher. When this is lower, this is higher. You show what? Liquid B. This is liquid A. So who is heavier? B heavier or A heavier? In that case, who is heavier? B heavier or A heavier? Zhong Jiayin. Zhong Jiayin, who is heavier? B heavier or A heavier? Zhong not allowed. A heavier lah.
B.
B, because this is lower, this is higher, means B heavier, lor, right? Heavier means it's denser. This is denser. This one lighter means density less. Okay. Okay. To see the formula here now, we pick 2 points, same level one. We pick point here and here. And then we say pressure at P1 here equal to pressure at P2. Why? Because same level means the pressure must be the same. Pressure here, P1 equal to pressure here, P2. First one, this one. Then put in the formula, the pressure, both are liquid, right? It's H1 rho 1 G. Here, pressure here is H2 rho 2 G, right? So your H1 here, your H2 here. Cancel the gravity because both sides gravity same. Then finally, you get this very important formula. H1 rho 1 equal to H2 rho 2. This formula is for us to find density of another liquid when density of one liquid is given. So you can find density of another liquid. Okay, this question usually came out one very common question. H1 rho 1, H2 rho 2. Remember the formula now? Okay, now example 2. Please answer this question now. Okay, come, you go answer this question. There are two liquids, put them together. Here 20 cm, here 5 cm. So this is water. Water density given 1000. So you're asked to find the density of liquid K. Can you do it? Okay, tell me the answer. Share your answer here, please. When the density of water is 1000, what is the density of K? Use this formula, please. This one you have just learned one. Use this formula. Anyone got the answer? How and Wang, these two boys here got answer one, but they don't want to show. They just keep it with themselves. How can you type your answer? Wang Yuhan, please type your answer there. Share your answer lah. Hey, two boy. Hao Hanzhi and Wang Yuhan, please type your answer. You see. Hao Hanzhi 250. Wang Yuhan, where's your answer? Wang Yuhan. Wang Yuhan also 250. Yes, correct. Okay, later lah. Who on one moment. Yang lain. Ganti dengan chip baru. Okay, sorry. Okay, both of them keep the answer 250. Now let's check the answer. Yes, correct. 250. Yes, very good lah. Huh? H1, row 1, H2, row 2. I just find the row 1, 250 kilogram per meter cube. Okay, that's the answer. Okay, okay, copy the answer quickly. Hurry up. Okay, now next is atmospheric pressure. This one I need to go very fast. Now we are going to know, why there is atmospheric pressure. This is different from gas pressure. You see the diagram here. Okay, this is our Earth. Our Earth is surrounded by one thick layers of gas, carbon dioxide, nitrogen gas, oxygen gas, so many types of gas here. All the gas has accumulated here is because of gravity, because of the gravity of the Earth pulling them down to maintain them in the position is because of the gravity. Okay, if no gravity all these gas wouldn't be gathered here. It will disappear. Then you cannot live here. You cannot breathe because no gas, no air, no oxygen. Correct? Not. Okay, now because of gravity, right? Gravity is pulling the gas towards the center. So when you pulling it down, right, it becomes weight. The gas having weight already because of gravity. So when the weight pushing down on your body, right, so it becomes pressure. So this pressure is called atmospheric pressure. So another meanings are why there is atmospheric pressure, because the weight of the gas surrounding the Earth. That is the reason. Understand? Okay, please highlight here. This one can ignore. Go to the second one. He said, the gas molecule possess mass and experience the pull of gravity. The result is that gases have weight. Highlight. Weight of the gas. Weight is in Newton, so we can say is force lah. Okay, when the force act on your body surface area, right, it becomes pressure. Okay, gases have weight. The weight of the gas molecule will produce force. As a result, will exert pressure on you, because pressure is force. Force means the weight of the gas acted on your body surface area. Okay, so this pressure is called atmospheric pressure. Okay, so now you know how this atmospheric come from. Atmospheric pressure come is because of weight of the gas, weight of the air surrounding us. Okay, and next one is more important. This one, characteristics of the atmospheric pressure. There are few important characteristics here. You know our atmospheric pressure surrounding us, right? So you must really understand the characteristics now, because it's very, very important to know, to understand what is surrounding us. Okay, the first highlight, atmospheric pressure act equally in all directions. This is number one. Later I will ask you, you better memorize it now. Characteristics of atmospheric pressure mean acted equally in all directions. All directions same one, up, down, left, right, or same, front, back, or same. Okay. Second, atmospheric pressure on any object not dependent on surface area. Important. This is number two. Please highlight. Okay, example means we don't care you are big size or you are small size. The surface area different. You are small size, you are big size, but you will get the same atmospheric pressure. This atmospheric pressure, we don't care one. Your surface area big or small is the same. Okay, that's why we say atmospheric pressure on any object is not dependent on the surface area. Same one, even a small, tiny ants also ants compared to elephant. Elephant and the ants so the atmospheric pressure treated them the same one. Okay. Next, third, atmospheric pressure is influenced by height of an object above the sea level. We call it altitude. This one is very important. Altitude means the height from the sea level. The higher you go up to the sky, right, the pressure, the atmospheric pressure will become lower. Why become lower? The reason is very simple. Because the higher you go up into the sky, right, the gas is getting thinner, getting less gas. Less gas one, On Earth here, we have a lot of gas, We feel very fresh. But when you go up to the sky, you find it not enough of gas for you to breathe one, So the higher you go up, the gas become thinner. When the gas thinner, density less already, so the weight of the gas also small. That's why the pressure becomes small. The higher you go. So atmospheric pressure influenced by height of the object from the sea level altitude. And as the altitude increases, the higher you go up, the atmospheric pressure decreases. So remember that the higher you go, the atmospheric pressure decreases, because the higher it is from the surface of the Earth, the lower the density of the air. The air becomes less air, density less. The next, we do not experience the atmospheric pressure. I told you last week already. This is another characteristic. We don't feel it at sea level because pressure of body equal to the pressure of atmospheric. Pressure inside our body, same as the pressure outside. That's why you don't feel it now. Okay. And the last characteristic, this one I told you already just now. Atmospheric pressure at sea level equal to 1 atm, 1 atmospheric. So we start from the sea level. Sea level pressure is 1 atm, 1 atmospheric pressure is equal to 10 to the power of 5 Pascal, 100,000 Pascal. Okay, remember sea level. We start from the sea level. That particular pressure is 1 atm or 100,000 Pascal. Okay, 1 to the power of 5 Pascal or equal to 76 cm of mercury. And with each water, 10 meters of water. Okay, so meaning that atmospheric pressure equal to 1 atm or 100,000 Pascal or 76 cm mercury or 10 meters of water. Okay, 3 minutes from now, memorize the whole thing here. The characteristics of atmospheric pressure. Okay, please do now. It's very important for you to memorize it before I let you go today. Memorize everything. When I call you, you need to make sure you know how to answer that way. File size 1, file size 3. Okay, come, memorize it now. Twenty seconds from now. Okay, time's up. Time's up. When I call your name, please surface yourself. Okay, first one I'm going to call is Chan Eng Sing. Chan Eng Sing, can you come up, please?
Yes.
Eng Sing,
Yes.
please tell me one characteristics of atmospheric pressure that you know.
Do not dependent with the surface area.
Yes, do not depends on the surface area. One, okay, thank you. Amanda Lee, one more.
Atmospheric pressure acts equally in all directions.
Yes, thank you very much. Regime, third, Regine Lima.
When the altitude increases, the atmospheric pressure decreases.
Yes, why? Why altitude increases? Because of?
Because the higher is from the surface of the earth, the lower is the density of the air.
Yes, correct. Thank you very much. Okay, next one. I must call a few boys to answer. If not, then the boy will feel they are very safe. Darren Chin. Darren Chin, can you come up, please? Darren?
Hi, sir.
Darren, tell me one more characteristics of atmospheric pressure.
Our body does not feel the atmospheric pressure at sea level because the pressure of our body is equal to the atmospheric pressure.
Yes, very good. Okay. And one more boy. Mignish, where are you, Mignish?
Yes, sir.
Okay, Mignish, tell me one more characteristics of atmospheric pressure that you know.
The atmospheric pressure at sea level is 1 atm.
Besides 1 atm, you can also call it
76 cm of mercury.
And also
10 meter of water.
And also one more
100,000 Pascal.
100,000 Pascal. Yes, thank you very much. Okay, right. I think you all understand already, Okay, now there are two questions here. Example 3, example 4. Please do it yourself. Okay, So I stop here lah. Anyone here you haven't sent your attendance, please send in your attendance. Okay, please. Anyone? And one more lah. Please remind those who not pass up their folder. Please do so. Okay. Please inform them to pass up. Help me to inform them. Michelle Chua, and Denise Kan, two of you. Can or not? I think both of you sitting together with them, right? Lim Yan Ming and this Esther Wan. Esther Wan, she messaged me yesterday. She says she want to pass up, but this morning I went to check. Don't have. She messaged me yesterday immediately. Says she want to pass up, but this morning I checked, don't have. Okay, and 5 size 3, there are few of them never pass up. Aiman, please help me to inform them. Mu, help me to inform your friend. Ask them to pass up. Okay, so I stop here for today. 5 size 1 and size 3. So okay, take good care of yourself. Okay, don't fall sick. Okay, and I see you next week. Okay, bye for now, everyone. Bye.
Thank you, sir.
Yeah.
Thank
Okay.
you,
Bye.
Thank you,
Okay.
sir.
Yes,
you, sir.
bye.
Thank you.
Okay. Bye. Okay. Bye.